Hello tribe, my name is Sibusiso, but you can also call me Coach Sbu. Welcome into the Maths Buddies channel. Here on this channel, I am dedicated to helping you solve math problems by providing solutions based upon your requests. So whether you're a new viewer or you are a returning one, if you find yourself struggling with any topic, please be sure that you leave that in this video's comment so that I can be able to generate a video for you so that you can basically get a solution to that problem. And lastly, please don't forget to subscribe so that you won't miss when another video gets uploaded. So without further ado, we want to jump straight into today's video. Now in this video, we're going to be looking at question 11, proportionality theorem or proportionality type of questions, right? So let's jump straight into the question as we given there. Now here in the diagram below, triangle ABC has D and E on BC. BD is 6 centimeters and DC is 9 centimeters. AT ratio TC is 2:1 and AD is parallel to TE. Right. Now before we go to your question, it is very important you first understand the instructions that you're given there. Right. Now here we are given the lengths of BD and DC and also a ratio of AT and TC. Right. So the first things first is we're told that BD is 6 centimeters, so I'm gonna go and write it there. So I'm gonna show you that is BD. So let me do that. So I know that the length of BD is what? Is 6 centimeters. Well, let me use a different color just to make it easy. There we go, 6 centimeters. And then DC, it is 9 centimeters. So DC will be from here. So I'm just gonna do it like that up until there. So that is 9 centimeters, right? And then the next thing that they did was they said AT ratio TC is equals to 2:1. All right, now this one we're given a ratio. So now what we're going to do is to work out the ratio. If we want to label it in the diagram, we always need to make sure that you don't label ratios in the diagram, but you label lengths, right? So this means now here on 11.1, I will say first AT over TC, which is AT ratio TC, it is 2:1, right? Now I know that we were given this, right? Then from there, I'll then say, therefore, let AT to be equals to 2A and then TC to be equals to 1A. So what did I just do here? So here what I just did was I introduced, right, a multiple, right, multiple A. So this helps me to understand that AT and TC are not actually 2 centimeters and 1 centimeters, but when I multiply them with a multiple there, then they can give me an actual length for what? For AT. So I'm going to take that and then put it there like that so that I can see what is happening. So this is 2A and then TC is 1A. all right, now this is going to then help me to understand a question or how to answer any question that has to do with the length of AT or any side that is in proportion with that. All right, so now here we say that, and then now the question here, it says let's calculate the numerical value, right, of CE over ED, right, CE over ED. So now I can then say now CE, right, over ED is in proportion with TC, right, over AT, right? So what am I saying? I'm saying therefore CE over ED is the same as TC over AT, and then I know that TC it is 1, right, 1A, and then AT it is 2A, but then this simplifies to 1/2, just like that, right? Now the reason for this, it is line parallel to one side of a triangle. All right, now here this then tells me that here now I had 1a there. So if I'm writing the ratio on the other side, I'm not going to write it as the length, but I'm just going to write it as 1b, right? 1b, and then here I'm going to write this as 2b. So because I know that here I have a ratio, but then if I want to label it there in the diagram, I need to use a multiple, and then the next multiple after a, it is b, right? Then here I also need to show it that I did that, right? So I said CE, it is 1b, and then ED, it is 2b. All right, and then that's all. So this is going to help me to find some other questions, by the way. So 11.2, they say now show that D is the midpoint of BE. Now if D is a midpoint of BE, right, we want to show that D is midpoint, right? This then means now that BD needs to be equal to DE, right? So I need to show that to DE, right? Now luckily I know that is what is the portion of DE, right? So I know that DE has a ratio of 2, right? So therefore I'll say then to find DE, right, I'll say it is 2 parts, right, out of 3 parts that we have, right, of what? Of DC, because I can see that it is 2 parts, and then that's 1 part combined. That gives you how much? It gives you 3 parts of DC. So this means now here it is 2/3 times 9 centimeters, right? And then you press that on your calculator, and then you get 6 centimeters, right? As you can see, this is equals to BD, and hence D is midpoint of BE. All right, so let's go ahead and continue with our questions. 11.3. So now here I don't just only know that what is 2b, I also know that 2b, it is what? It is 6 centimeters. So it's very important that every time when you do something, you update your diagram so that you can see what is happening. And then of course, if that is 6 centimeters, that is automatically 3 centimeters, right? Now the question now, it says if FD is 2 centimeters, if FD is 2 centimeters, right, now calculate the length of TE, right? All right, so now what is happening here? So here we are told that FD is what? Is 2 centimeters. All right, so like that, FD, it is 2 centimeters, right? Then now they're saying let's find what is TE. Now here what we see here is that AD is parallel to TE, right? Now if the lines were parallel, right, if we had parallel lines and then you were told that this other parallel line, it created a midpoint into BE, that parallel line will then mean that it is also parallel to the other side, right? So that's basically what is happening here, right? So what is happening here is that here we have D being a midpoint, right? This then means now if D is a midpoint, then it makes BF, right? It makes F to be a midpoint of BT, right? You can also prove that by basically calculating the ratio using proportionality of BD over DE, and then you'll see that when you calculate that with BF or FT, your answer is going to be 1. Now because of your ratio is 1, then it means this point divided BF and FT equally, right? So this then means now here we say now to find the length of TE, we're gonna first say here we're told that FD is 2 centimeters, then they're saying length of TE, right? Now we're saying now to find that we're gonna say BF BF over FT is the same as BD, right, over DE, which is 6 centimeters over 6 centimeters, and that is equals to 1, right? Now this is because of line parallel to one side of a triangle, right? Now because of the ratio is 1, now since BF over FT, right, is the same as BD over DE, and they are all equals to 1, then this means that F is midpoint, right, of BT, and D is also midpoint of BE, right? Now because of they're both midpoints, right, therefore it then means that because of F is a midpoint of BT and then D is a midpoint of BE, it then means that BF is equals to FT, right, is equals to BF is equals to FT, right, whereas BD is equals to DE, which is what we basically know already, right? So we're saying this, what are we saying here? We're saying this is equals to that, right, and then we're saying that one is equals to that one, right? Now the minute you have something like this, this is what we then call a midpoint theorem, right? So this then concludes that therefore, right, FD is half, right, is half of TE, right, or you can say TE is twice FD, right? Then this is what midpoint theorem. And then now here, as you can see, we had FD as 2 centimeters, so therefore 2 centimeters is going to be equals to TE over 2 cross multiply, so 2 times 2 centimeters gives you TE, and therefore TE is equals to 4 centimeters, and that is the length for TE. All right, now let's go ahead and look into the next question. Next question, we calculating area ratios, right? So we're gonna keep going back into this one because that is where we have a lot of information, as you can see there. So let me just put in that 4 centimeters there, but it's not gonna assist us, but it is good to always update. We'll never know. All right, so let's go ahead and look at this one. So in this one, we want to calculate the area of triangle ADC, sorry, over the area of triangle ABD. All right, so whenever you're doing area ratios, right, you always need to make sure that you take note of the type, right? Now here we're first going to look into triangle ADC. Now let's see where is triangle ADC. So I'm going to draw triangle ADC. Now there's ADC, A, D, C, like that, right? And then now from here I'm going to look at ABD. Now ABD will be ABD. Now here our types of proportionality, there is 2 types, right? It's either these 2 triangles, when you're finding their ratios, they have the same common perpendicular height, right? They have the same perpendicular height, or they share a common angle, or meaning they have the same angle. Now in this case here, we can see that they don't share the same angle, but they do share what? They do share the perpendicular height there, right? Now because of they share perpendicular height there, then this means now when we calculate the area of this, right, this will then mean the area or the ratio of their areas, right, is going to be the ratio of their bases, right? So what does this mean? So this means if I'm calculating the area of triangle ATC, I'm going to use half times base. Now the base is going to be DC times height, I'll just call it H, over, and then when I'm doing ABD, it's going to be half times the base is going to be BD, right, times the same height, which is H. Cancel both, right? You get what? You get DC over BD. Hence we then call it what? Call it the ratio of their bases. Now this is what type 1 is about. That is the type 1 area ratios. Alright, now we're gonna go back into the previous slide to see if we had the length for DC or we had the ratio for DC. Now here, remember, we knew what DC was. DC is 9 centimeters, right? So we have 9 centimeters over, and then BD was 6 centimeters, so 6 centimeters. Now this gives us 3 over 2, and that is the answer for that one, right? Now let's look at the last question, which is 11.4.2. so this was 11.4.1 under 11.4. Then now we're looking at 11.4.2. all right, now let's look into this one. Now in this one it says area of triangle TEC over area of triangle ABC. Now we do the same thing. What do? We first draw the triangles so that we can see what we're talking about. Now I'm talking about TEC, so there is TEC, and about ABC. Now there is ABC. Alright, now what do we see here? So here we see that here, first of all, they don't share the same height, right? And then here, what do we then see? We see that they have the same angle, right? So if they share the same angle, this then means now basically what we're going to do is we're gonna write the type 2, right? Now how does the type 2 works, right? So the type 2 basically uses an area rule, right? So when you're calculating the area of triangle ATC, we're gonna say 1/2 times, now we're gonna say TC times EC, right? Now the reason why we're saying TC times EC is because we want to focus on that common angle there. So it's going to be TC times EC, right? And then we're going to multiply this with sine C, right? Over, now we're going to say again, the bottom one is going to be 1/2 times, then now with this one, we're going to be AC times AC times BC times sine C, right? And then as you can see there, this cancels with that and this cancels with that, and then here we're gonna get TC times EC, right, over AC times BC, right? And then now we're gonna go into our info and see if we do have those values, right? So here, firstly, we do have TC, right? TC is 1A, right? Okay, and then EC, we actually have the length there, that is 3 centimeters. And then we're gonna try and look at EC. Do we have, oh, there was EC, so what about AC? AC, it is 3A, as you can see there. Then what about BC? BC, it is 15. All right, so this then means now here we're just going to substitute our values. So we said AC was 1A times, and then EC we said it was 3 centimeters over, and then we said AC it is 3A times, and then BC we said it was 15 centimeters. Now this A, as you can see, it's going to cancel with that, and then the 3 here is going to cancel with that, and then our final answer is going to be 1 over 15, right? And that is all for this type of a question. So that's all I got for you today, guys. If you liked the video, please make sure that you like and then you share it with other people, and also leave me a comment and tell me how you feel about this video. And don't also forget to leave me a topic there that you would like for me to cover into our next video. And until next time, guys, stay blessed by the best, and I'm gonna see you on to the next video. Cheers.